Hi everybody, and welcome back. This will be part 5 of the dual slot furnace, but I mean, really doesn't matter calling these parts and stuff, as they're really each individual components that could be viewed separately and kind of looked at as individual things. So what we're going to work on here is the shift-click ability of the container. And now a container is like any kind of GUI you have open that has an inventory on it. So your player would be a container, furnace is a container, chest, so on. The shift-click ability does have to be programmed. In the future, I do plan to work on some kind of methodology so we don't have to deal with programming it. It's just a bit of a tedious thing. Now, I did go ahead and copy the campfire's shift-click, because the campfire shift-click works rather well. It's actually kind of nice. And then I went ahead and I pre-put some stuff in here so we don't have to think about it a little too hard. Now, this might work. It might crash us. I'm not 100% sure, but let's go ahead and work our way through it real quick before we start. So when you shift click, it's going to go and take, okay, we have some kind of slot that we're shift clicking out of, and we have a player who's doing the action. So you actually, I think, could block shift clicking from a player. I'm not quite sure. I've never done it before. I rarely play with the shift click ability for transferring items, as it's not something I really like to mess with, and I'm not much of a fan of doing GUIs in general. So you get the contents of whatever slot comes from that slot index. So you get a slot, which we're going to actually set the final so you can't change the slot. So this is what we're working with. We're actually going to make sure the slot isn't null and that we actually have a stack in the slot, which this would actually throw an error if that was probably null. You actually could put a null slot in here, it's just it would be unconventional to do it. So it won't have my mistake. If there's a null slot in here, somebody fucked it up. But we put a null check in there anyway, so not null, has something in the slot. If there's nothing in the slot and you shift click it, there's no point running code. First thing we do is we do for outputs. Now I have not actually set this up properly, and we'll have to go through it like a little bit. So that we have two output slots, and we actually need to make sure these aren't campfires. So we have two output slots here. So, and these are actually probably called output slot instead of slot output. I'm not exactly consistent with my naming of my fields. It pretty much changes a lot. It doesn't matter too much though. What we're looking for is a number, so we're trying to get the slot index equivalent to number. We actually could do instance of checks on here as well, so you could go, okay, if slot is an instance of an output slot, or slot is an instance of an input slot, or filter slot, we could do it that way. That actually would probably work really, really well too. If it's an output slot, we want to send it to the player's inventory. Now we do need to make sure we're using the correct indexes. So you want this point, and we want this point. And this will send it to the inventory. We'll have to check to make sure these numbers are correct. Our inventory is 6 slots long. And we're using this as both a start point and end point. And we'll go ahead and document that. Because when you go ahead and to merge the stack, how the merge stack goes, stack you want to put in there, the starting slot you want to start looking at, and the last or the end point. So this will be I'm trying to think of like a best way to explain this. This will pretty much be a slot plus whatever you're going to stop at. So if you only wanted to put in one slot, this would be 0, this would be 1 if you wanted to insert it into the 0 slot. So it would stop when it hits 1. It's a little confusing, as I really think there should be a better handling for this method. And I might actually write some custom code in the container called merge through slots or something that has a different naming scheme but is a little easier to use. Especially when you consider that there's some differences here, like there's a true here, there's a false here. I have not documented the difference, and I have reverse engineered this a few times. K minus 1. Interesting. Okay, so you know that thing like I was saying, like this is the last point? Apparently if you set this to true, it'll actually take and minus that by 1. So apparently there is some logic here. We'll toy with this maybe. Anyway, so we go through, and this output slots are going to go to the player's inventory. If we are in the player's inventory, which is what this check is going to do, if our slot index is above our inventory in, so it'll be from slot 6 onward, then we're going to try to put it in certain slots. If it's a smelting item, it goes into the smelting slot. If it's fuel, it goes into fuel slots. anything else, and it goes back to the player's inventory pretty much. This one does, I think, the hotbar, so this will be input slots, fuel slots. So if it's greater than, so this is a hotbar, and this would be main inventory. And then we have an if else in statement, so like if something fails, it'll just move it around the inventory. So if you shift click, so this would be fail state. And of course we make sure that if our stack size is actually needs to be less than equal to 0, so if something fucks up and we get less, we set the null. We do onslaught change, which to be honest should be called in all cases technically. I think put slot actually calls it automatically, so we don't have to worry about it. If item stack equals stack size, we return null because we didn't do anything. If we actually return null on this, I think it'll just stop caring. I gotta read the documentation on this one here later. But let's go ahead and get it launched up so we can at least test it. This won't be a long video, it'll be pretty short, that way we can move on to what's after this. So I said we would work on... Oh yeah, doing some advanced rendering, so that way we could make some really cool effects. Now I'm only going to really do this advanced rendering because I'm more or less bored and need to have something to entertain myself. As even though I know the client wants that as well, I probably should charge him more for it. Because I am definitely not getting paid enough to do all this work, but I'm putting extra in it because he's a nice client, might as well give him some extra for being pretty good about paying on time and stuff. So yeah, here's where we copied it from, by the way. So this guy works. We're actually going to test this guy real quick just to make sure he works as well. And we may spend some time, if this video is not too long, going through some of the other tiles and making sure that their shift-click support works as well. I know the sentry guns have some problems. Their shift-click does work, but it results in a ghost item in the player's inventory. We need to fix that. It wouldn't take long. I believe, if I remember correctly, this shift-click support is built off of the actual tile entity furnace. So I went and took the campfire and I went and looked at the furnace code. I mirrored the furnace code, and so in extension we're mirroring the furnace code in this one as well. Again, it's a little bit more complicated because we have 2 slots to deal with per setup, but it works about the same in theory. To be honest, I really should just run this method twice, but I know for a fact that both of the fuel slots are 1 plus each other, so plus, 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 plus. But if this ever changed in the future, I'd probably have to run them independently. Well, the thing is, when we go to implement probably a JSON version of this in the future, how it's going to end up working is we'll probably put a method inside the slot called slot can insert, and I believe that actually is already a check built into every slot, so we wouldn't have to add any extra code, and we would just go, okay, if you can insert, just insert. And we would go, okay, if it's outside the player inventory, we try to insert it to the tile. If it's inside, or if actually if we're going from the player inventory, then we would try to insert it into the tile. We would just go through all the slots and try to get best guess. And then we'll set up some kind of JSON system like which slot should be prioritized over others. That way you're not just guessing. Like we want smelting materials to go in that slot first, but there's things that go into the smelting slot that actually can end up in the fuel slot. And there's things that go in the fuel slot that can end up in the smelting slot. The reason why we prioritize the smelting slot is more than likely people are going to be shift clicking into the smelting slot. So you got to think from a user perspective, from use case, like what's more likely to happen. And the more likely thing is that the fuel slot's already got stuff in it, and you're going to want to prioritize like putting chicken into the furnace slot, or a piece of iron ore or something. This will change per machine. Like you may have machines like you want upgrades to go in the upgrade slots rather than into a secondary inventory. But then if I shift click in, say, something else, it may go in the second inventory instead of going into the upgrade slot. There may be certain logical behavior patterns that need to be kept in check to prevent problems. Although it's unlikely. We're just thinking of some of the complex stuff. I'll figure it out though. I'll run through the use cases here later in my head. For those who, by the way, don't understand what the use case means, it means literally exactly what it sounds like. A single instance of a use, or a single set of uses. So think of like taking a can of like soda out of your fridge. A use case is opening the fridge, but there's also the use case that you go to open the fridge and it doesn't open. That's actually a use case as well. So it's both the good thing and the bad thing, both the proper steps and the improper steps. I could try to push the fridge door in instead of pulling it open. That is actually a use case. Programmers think about that stuff. This is working. So what we want to do is check shift click, and we just found the first crash. This is going to happen a few times while we check inventory length. And yeah, index out of bounds, so we're one size too big. So hotbar endpoint is too large. I think I see what we might have done wrong. Okay, we're 36 slots for the main inventory. That includes the hotbar and that, and I think the hotbar is 9 items long. So our hotbar, our main inventory is only 27 slots. So that's what's messed up here. So I was pulling code from the other version, and we can check this real quick too if I open up the campfire. Yeah, so 3 plus 27 gets you that number. So that's what just caused that crash, is that was the wrong number. That's why I put these up here, by the way, too, is that I can change these up here and I don't have to come through and change them all down here as well. It's always good to make sure you use constants best as possible. It also makes readability really good, and then it makes maintaining the code even better. So even up in this case right here, like, these are what was in the dev community is called a magic number. Is you don't know what it's doing. It's magically applying some kind of meaning to it, and you can't just determine that meaning from just staring at it. I mean, of course, somebody's gonna look through this and go, well, I'm just moving this box by 17 or something, or I'm setting its position to 17. But it would be good to actually set these up in constants, even though it would feel unnecessary, just because it would improve readability. So you can go input slot starting point, and then, or input slots Y level is what this would be called, and then you would go right here. This would be input slot to X position, or X offset. Exactly what this would be with X offset. Actually, we could call it position. What we could do is we can also like make these static, because these can all be calculated. And if you make them static final, they only have to be calculated once, and then you never have to update this again. This will actually, using constants does make your stuff run faster, so there is actually advantages to it, because when you come down in here, you have to instantiate that, then you have to set it to 16. Then you come down here, and then you have to go, okay, 16 plus 24. And it doesn't sound like a lot. It really doesn't. And to be honest, it's like nanoseconds time it saves. But hey, if you could save just a little bit and make the code more readable, it's a win-win. And readability is probably the more important factor of that, because I think when it comes to performance, this may be 12 nanoseconds at most. It's probably even less than that. Like, I can't even think of how, I'm not even sure how long it takes to do an addition. I know it's stupidly fast. Like, we're talking about your processor on your computer can do billions of additions before you even realize there was a delay. Mainly because, well, processors are good at this. It's machine level based actions. I think it takes longer for Java to realize what's going on than the processor to do anything with it. I think it takes it longer for it to transfer from memory to the processor than it does for the processor to calculate that. And usually, by the way, when you're dumping stuff on the processor, you're not just transferring one method here. You would be running like all of these lines, probably dumping them all into the processor. I'm not sure if Java has the ability, but I think it might understand that you can simultaneously run these. I doubt it. That might be wishful thinking. I know when I was studying how languages work at a fundamental level, I was actually taught that there is a few languages that parallel process. That when the compiler understands that all these lines can run at the same time, it will dump them all into the processor at the same time and say, okay, hey, you can run all these, and I don't care what order they come back in. I'm trying to think of what languages you could do that with. Although it's a bit of a more advanced programming, because what you're doing is you're messing with the registers on the processor, which if people, I know most people don't know what registers are, but they're these little memory storages on the processor that actually will store what the value of X is, what this number is, which is 24. It will store the operator, and then while it waits for the processor to take over, it'll then go and it will take it from that registry, put it into the processor will calculate it, and then pull it back out, put it in the registry, then the registry will go, hey, I need to transfer it back to the memory. And it'll transfer back to the memory. Or something like that. I have like a really light understanding of how that stuff works because I'm not a hardware person, but as a programmer I'm required to understand how the hardware works at some level. But yeah, we got off topic though. The whole goal of this video, and I probably should be better about staying on topic, is working on the shift click. Yeah, it's going to send it to that first slot. And what we could do is we could program this so that this way it tries to do multiple slot types. And it will look, it does both slots. And we can shift these, and these guys, unfortunately, will try to go to the output slot. So that is a problem. We don't want it to go to the output slot. I think this is a bug the campfire has as well. And I'm trying to figure out what exactly could be causing it. So if we're transferring out of the input slots, cool. Then if slot index is greater than inventory else, it tries to merge it back into the player's inventory, which is inventory end to that. So how does it manage to end up? Ah, right here. That's how it ends up. So this would be inventory start to inventory end. We just missed a spot. There we go. So I can't shift it back in that. Now, can I stick it in there? No, so it won't let me. So it does look like this tries to stick it in the slot even if the slot won't accept it. This code merge in probably should have a check somewhere in here. It doesn't. So yeah, we just go is stackable. Then we just make sure the two match each other. I could optimize this method down. I might actually do it later. Yeah, at no point does it try to ask the slot if it's allowed to be in the slot, it just merges it into the slot. So the very first thing that should have ever happened when it goes to merge in here is when it gets a slot ID, it should actually attempt to ask it, hey, can you go in there? Although that's something we should check before calling merge, but it would be nice if we could control that. Anyways, let's go ahead and check Campfire before I hit restart on the game client here real quick. So I want to make sure I can, the shift clocks work on this. So I can't shift anything up there, so that's good. Now let's go ahead and get some fuel. And we'll get some food as well. So that goes in the fuel slot. And I grabbed uncooked, or I grabbed cooked version. And that goes in there. And it's working, so I can click that out, click it back in, click it out, click it back in. We do look like we have some rendering problems with this. That's not really too big of a concern. I don't really care, to be honest. Yeah, see there's a problem with the arrow popping up there. That looks like that's an issue with the fire itself, and I actually think I understand why that's happening. It's just probably a rounding problem. I'll fix it later. I'll just remember it's there. So that's it. That's what shift clicking. It's really not as complicated as it looks. I used to think it was complicated as well, but all you're doing is you're going, okay, if I'm clicking from a slot, where do I go? So if I'm clicking from an output slot, where do I go? I go to the inventory. And it's the same thing over and over again. If I'm clicking from something, I go to something else. And really, really weird is that they're different behavior in different spots. Like, okay, so if that's, okay, yeah, that's good. There's a bit of a oddity to this. Actually, we should never make it down to this point. I just realized that. These are fail safes down here. And yeah, these are fail safes as well. Cool. So that's the end of this episode, and we'll be back here with some more advanced rendering, and I'll figure out what we're going to do after that.